Okay, today we will going to next problem of the problem for the numerical method of differentiation. And to this problem, we would like to use central difference approximation to estimate the first and second derivative of this function. We have the coefficients constant a of the first term of the 7-degree polynomial. We would like to take the first derivative and second derivative to this function and would like to find the value at a specified point x equal to 1 at a specified point x equal to 1 for h equal to 0.1. Okay, for h equal to 0.1. This is the given value. That is, you have to follow the given value. Okay, and compute the exact solution and true percent error for each approximation given a equal to kn times 10 power minus 4. Okay, so this is just the example of the problem, like the exam as you have done. Okay, some students do the exam with something that is not follow the instruction of the exam. Some students do not use the initial case as kn, so I don't know why. Okay, so actually if you do like that, okay, and you have no reason enough, okay, so you will get 0 for that. Okay, so that is mean that you do not understand anything at all. Okay, so the problem that's we have something that is we have to follow for the case that if the problem gives us that you have to use this value, so you have to use that. Okay, if you would like to use another one, so you have to have a reason that is support your method, that it should be enough. Okay, so for example, if I would like, I give you the initial case, some initial case, but you prove that, okay, that initial case, okay, you already done, and you found that some value that is maybe closer to the solution. For example, you can, if you prove that, okay, you can change, but most students do not do that. Okay, you change, but you use the I don't know, you use the initial case as the task activity that is not suitable, so you get the solution that is not close to the predict solution that should be. Okay, so that is your mistake. Okay, because the problem is guiding you already, but you do not follow that. Okay, so sometimes I think the instruction of the problem you have to read. Okay, and some students do not use the method that guide you. For example, part two of the exam, you have to use second method, but you use Newton-Raphson method instead. So why you do that? Okay, because we would like to make sure that you understand the second method or not. Okay, and the question asks you that what the concept of open method, but you answer that the concept of second method, so it's the wrong answer, right? So I think it's sometimes you have to careful to read the problem carefully. Okay, so that is just something that is maybe the new generation. I don't know. Actually, it's just maybe not only new generation. It's maybe something like most people do not like to read too much. Okay, so but something that is maybe more important to yourself, you have to carefully read and carefully do something. Okay, so something like this. Okay, the problem is given us that we have the function like this and we have the coefficient a. Okay, so for today, who would like to who would like to help me for this problem? Who would like to help me to solve this problem? Who would like to help me for calculation? No one, right? No one? Who can help me, please?
Yeah, I can help you.
Okay, give me your KN, please.
Okay, 21962.
21962, okay. 21962. Okay, this is KN for today. Okay, so we will use KN as 21962 for this problem. Okay, so to this problem, so what does it mean? It means that fx is equal to, okay, 2.1962 x power 7 minus 3x power 5, okay, minus 14 x power 3, right, plus 3x, okay, minus 2. Okay, to this problem we have to determine the exact solution also. So it should be better if we solve the exact solution first. Okay, so for the exact solution, because it is a simple problem, right, we can solve for exact solution analytically. So for the exact solution, f prime x is equal to what, please?
Is equal to 15.734.
15.3.
734. No. 3734.
Okay, this is correct.
X to the 6. To find the first derivative. Okay, and next is minus 15x to the 4. And then minus 42x square.
This is correct.
And plus 3. Yes.
Okay, so what is the exact solution for this case when we substitute x equal to 1, because we would like to find the first, okay, oh sorry, we would like to find the second derivative also, sorry. The second derivative is what?
Okay, please wait a minute. It's equal to 92.2404. X to the 5th. Yes, minus 60 x cubed minus 82, 84. Sorry. Yes, x. Yeah, that's it.
Okay. So for this, if we substitute at x equal to 1, so f prime x is for exact solution, right?
It's equal to minus 38 minus 38.6266. Oh, sorry, teacher. Sorry, I missed some term. It's equal to minus 53. 53.6266. Yes. And the second derivative, I will calculate it. Is equal to minus 51 point.
I think the first derivative, this is correct.
4596. Yeah, it's wrong. Okay, I will recalculate it.
First derivative is correct. I don't think so.
Oh, sorry. Sorry. It should be negative. Negative. 38. Negative 38, and in the decimal point it stay the same. Yeah, sorry.
38, right?
Yeah. 38. Point 6266. Yes. And okay. Yeah.
So you see that. Actually, the second derivative is correct or not? Repeat it again, please.
Okay. Please change the decimal point, please. It should be 0.7596. 51.
Okay. So as you see that,
0.7596.
From the solution, as your friend helped me, okay, you see that it's actually it's not hard, but in calculation, it's maybe we may have some mistakes, okay, in order to solve in the exam, or we have in many calculations. So you have to repeat it again, okay, to make double check of your result at each step, that is your result is correct or not. If you do it again, so you will get the better solution, okay. So yeah, carefully check, okay, the calculation. That is very important for this topic, okay. Okay, we have done for the exact solution, right? Now we move to the numerical solution. What is the formula for the central difference? F prime x is equal to what? It's equal to F xi plus 1, right? Minus F xi minus 1.
This is an error of order s square, right?
Sorry?
This is an error of order s square, right?
Yes. It's just if the problem is not mention anything, okay. If the problem is not mention anything, it means that we will use the general finite difference formula. General finite difference formula is mean that for central is the error of for OS square, okay, and forward is OH, and backward is OH, okay. But actually, if we have to do both in the same problem, and we would like to solve the solution that we necessary to use forward and backward, as you will see in next problem, we should use the formula with the same order. So forward and backward should be upgrade to the more accurate solution, okay, more accurate formula for that case, and we will go to that case next problem, okay. To this problem, just use the general formula. For this case, we mentioned that we will use central difference. As I mentioned yesterday, I told you that the central difference is okay for the general formula. It's good enough for most engineering practice. Okay, it's not necessary to use more accuracy formula. Okay, it's okay if we use the small value of h. That is h is if we select h is small enough, so central difference with general formula with the order of the error of OH square, it should be enough. Okay, so formula is okay, and for the second derivative is so according to this, how many value that we have to find, okay, for value of x?
3.
Okay, this is for xi minus 1, right? This is for xi, this is for xi plus 1. Okay, xi is equal to what?
1.
Xi for this case is 1, right? And h is given as 0.1. So xi minus 1 is
0.9.
0.9. Xi plus 1 is
1.1.
1.1. So then we substitute with this equation, right?
Yes.
Okay, do not confuse. Do not confuse with the exact solution. The solution should be in 6 digits.
Okay.
For another
For
student, you may use your KN. You may use your KN and solve it by yourself and check yourself.
okay, for the value of function, I already calculated.
Okay.
For x equal to 0.9, right, is equal to is equal to minus 10 minus 10.227 0.34. Next, I would like to calculate 1.1. This is negative 17.
1.1, right?
Yeah, 1.1 minus 17 .885. 758. Okay, the last one I will calculate for 1. When x equal to 1 is equal to minus 13. Point 8038. Yes.
Okay, we already have the value. So we will approximate the first derivative and second derivative from this value, okay? So for first derivative is what?
Okay, please wait a minute. Is equal to minus 38. Okay. 0.29362.
Six digit.
Yes.
6 digit.
Oh, it's also one is will become 0. Oh, in the last one 0. Yes. Okay. Okay. It's equal to minus 50. 0.5192 and double 0.
Okay, so now we get the solution, right? And after that, we have to find the percent error with respect to the exact solution. For the percent error, for this case, what is it?
Okay. Minus 38.0.29362 minus with the exact one. Percent error is equal to 0.862.
Okay, because the percent error, as you see that with step size h equal to 0.1, we got the error is approximately 0.8%. That it should be okay, right? It should be okay. Okay, but actually in numerical simulation, in my opinion, it's still not enough. Okay, it's still not enough. We would like the error less than this. Okay, normally we will set the error is just like if we determine just relative error, it should be less than 1 times 10 power minus 5 or something. Okay, that is maybe acceptable. So the step size for research is maybe less than 0.1. It's maybe just h equal to 0.01 or something. Okay, you may try it by yourself. If we use h is equal to 0.01, what happened to that? You may try it by yourself to find the solution. Okay, so for next, 40% error of second derivative. What is it?
Okay. Could you back? Okay.
So what is that?
Okay. Is equal to 2.396 464.
Okay, you see that? For first derivative, the percent error is 0.8 or to 0.9%. It should be okay, right? But for second derivative, it's maybe not good enough. Okay, the solution is, in my opinion, is not good enough. Okay, but for some problem, it's maybe okay. So you have to, as we are engineer, okay, we have to make decision what it should be okay for that. Okay, but for distance, it's maybe not enough. The error is too much for second derivative. Okay, so if we know like this, when we going to solve the problem, that we will apply the central difference or finite difference to approximate the differentiation term. Okay, we have to concern about this error. Okay, we have to concern about this error. That's we may got some error from this case. So in order to reduce or to get the better solution, we have to use the step size or the incremental of x should be small enough. Okay, and if you would like to find the better solution with the small enough value of x of delta x or h, okay, it may take a long time for calculation, but we have to check. Okay, in research we may check that the suitable h, the suitable step size should be what for research. Okay, in some time we may check it before. Okay, if we use the h, for example, if we use h is just equal to 0.1, for example, like this. Okay, and after that we check, we may use s is equal to 0.05. Okay, compare the result. Is close to each other or not. Okay, if it's very close to each other already, so it means that the solution that is smaller than 0.05 is maybe not necessary or something. Okay, so we may find out what is the suitable S before in research. Okay, but in the problem that's for the exam, I will I will given you that what is S that you would like that you have to solve. Okay, so for this problem is a general, right? So it's not hard. Okay, so do you have any question for this?